a huge lesson, but I think you guys usually when we do it this order, the way that we've done it, you guys put it together pretty fast. Okay. All right. So we're moving on from triangles for a hot minute. Okay. We're moving into parallelograms. Big essential questions. If a quadrilateral is a parallelogram, what are some conclusions you can make about its angle, sides, and diagonals? What information about the angle, sides, or diagonals of a quadrilateral allows you to conclude it is a parallelogram? So this will answer that question that's in your mind. What the heck is a parallelogram? We're going to try and prove and apply theorems about parallelograms, use properties of parallelograms to solve problems, prove that a quadrilateral is a parallelogram. So we're right now working on two big things: quadrilaterals and parallelograms. Okay. Right. If you need that, I'll come back to it. Okay, let's get this. Okay. Any polygon with four sides is a quadrilateral. Stop. Period. End of story. Any polygon with four sides is a quadrilateral. Okay, any polygon with four sides is a quadrilateral. Nope. Okay, just write that down right now. Any polygon with four sides is a quadrilateral. I got more comments if you need them. Okay. All right. Notice it says this helpful hint. I don't think you have to write this down. Opposite sides of a quadrilateral do not share a vertex. Opposite angles do not share a side. Right? And it's kind of like in words, that doesn't mean anything. Once I show you a picture, that'll make perfect sense. Okay. All right. Still work clear. A quadrilateral has how many sides? Four. What do we call a four-sided polygon? See the word square up there? You're going to get messed up if you start talking like that. I'm not lying. Polygon with four sides is called a what? Quadrilateral. There are some quadrilaterals are special, and we call these special quadrilateral parallelograms. Okay, so our hierarchy: quadrilateral, parallelogram. Okay, anytime you got two pairs of parallel sides in a quadrilateral, you have a parallelogram. We were very original with our name, right? To write the name of a parallelogram, use the symbol parallelogram. So notice how it says parallelogram ABCD. You cannot name it ABBC. You cannot name it ABBC. You cannot name it ABBC. You cannot name it CABD. Go in order: ABCD, BCBA, CDAB, BABC. Look at the opposite sides in this parallelogram. AB parallel with CD, BC parallel with AD. So far, that's all we need to know. So far, not too bad, right? I'm going to give you a hint about what's to come. Okay? Usually it helps when I give this hint. Here is what's to come. Polygons with three sides, what do we call them? triangles that have right angles, what do we call them? You don't have to write this down. Just watch. Any shape, any shape, any shape that has more than two sides. We don't call it two-sided figure. Call a line and another line, right? What do we call a four-sided polygon? Quadrilateral. See why I told you you got to know it? Quadrilateral. You don't have to write this down, just watch it. A special type of quadrilateral where the two opposite sides are parallel is called a parallelogram. Okay? See that? Right? Not every quadrilateral is a parallelogram. Okay? It's possible to have a four-sided shape without it being a parallelogram, correct? It's possible. Don't give me that look. Is it possible to have a triangle that's not a right triangle? Yeah, we did it for like 6 weeks, right? Now in 2 days, we're going to get this. It's possible to have a quadrilateral that's not a parallelogram. Here's the big giveaway. If the opposite sides aren't parallel, it's not a parallelogram. Just like if there's not a right angle, it's not a right triangle. Okay? So see that? You got to make that connection with it. Okay? Got to get you there. Tomorrow, we'll see that some parallelograms are called rectangles. Some are called rhombuses. Okay? And when those two hook up, they get squares. Okay? That is your math hierarchy. That's your geometry hierarchy. It can be difficult to sit through, okay? Because you're going to get questions like this. Are all quadrilaterals squares? No. Okay? Are all squares quadrilaterals? Yes. All squares have four sides. You first. No. We'll talk about it tomorrow. It's a quadrilateral. It's a parallelogram that has four congruent sides. Okay? But that's tomorrow. So come back tomorrow. Send it to come. All right? But do we see our hierarchy here? Right? Okay? We just came from this whole study of triangles for like 6 weeks, right? We talked about it, and you guys know that not all triangles are right triangles. Well, not all parallelograms, not all quadrilaterals are going to be parallelograms. Not all parallelograms are going to be rectangles. Not all rectangles are going to be squares. Here, I think we just talked about this, but let's make sure we got it. Okay? One of the principles, one of the properties of a parallelogram, not only are the opposite sides parallel, they are also congruent. Write that down. Just write down that the opposite sides are congruent. In a parallelogram, the opposite sides are congruent. You may want to have like a checklist going down, okay? Got me? I would put like this. I would do it like this. Parallelogram. Got me? And I'd say opposite sides parallel. Opposite sides congruent. And yes, we will add to that. Okay? We're going to add a couple more principles. Opposite sides are parallel or congruent. What's more, the opposite angles are also congruent. The consecutive angles are supplementary, and the diagonals bisect each other. Okay? So, again, I told you, make that checklist, right? Got me? Add this to your checklist. Opposite angles are congruent. Consecutive angles are supplementary. We'll talk about what that means in a second, okay? Consecutive angles are supplementary. And the diagonals bisect each other. Add that to your checklist. You should have 5 things on your checklist. A parallelogram. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Those 5 principles are crucial to understanding what the heck is a parallelogram. Than anything else. But we're going to move on and finish this one, okay? The formulas are tough, right? Well, it's not to be tough, it's remember what problem. That's the class. You're right. No, Ethan's right. That is the class, okay? That's the class. The class boils down to this formula versus this formula, right? What am I supposed to do? I'm supposed to set them equal, and I'm supposed to add them up to be 180 degrees, correct? That's a part of the class. That's why we take notes in here. Why I would hope that you review your notes, you know? And if you aren't doing this, maybe you should. Just say again, okay? You should go home and review your notes. Probably nightly. 5 to 10 minutes, just looking at math. The most boring 5 minutes of the day, right? Okay, I'm very honest. That's going to be the most boring 5 or 10 minutes of the day. But reviewing those principles after, let's see, 8 hours later, right, is going to help reinforce what you learned in the morning. So, one thing. All right, here we go. We got to move on. Really. In parallelogram CDEF, DE is 74. Find CF. What is CF? Okay, it's parallel. Remember, I did it to you again. Oops, I did it again. Hit me maybe one more time, right? Okay. I got 5 principles that I just gave you about parallelograms. Now we're just trying to apply it. The opposite sides are parallel and the opposite sides are congruent. Okay? Congruent, right? Right? Here we go. DE is 74. DG is 31. And FCD, it's like the big angle, FCD, the big angle is 42. Find EFC. EFC. Okay? Here is where you got to know what consecutive angles are. It's very easy. Things happen in consecutive order. What does that mean? Who has ever attended a baseball game? Who's ever played baseball? Or softball? So when I say this, okay, are y'all familiar with baseball and softball at all? Kind of? Okay, if not, here we go. Baseball, we'll just any baseball. You have a batting order, correct? You say that's first, add that second, add that third, fourth, fifth, so on and so forth, right? If you hit, listen to me, if you hit back-to-back home runs, what does that mean? Who hits the home runs? Which batters? Be more specific. The batters that are right after the other, correct? The consecutive batters, right? You got me? The consecutive batters. A back-to-back home run. Okay? When you're looking at your angles in a parallelogram, the angles are written in consecutive order. So D and E. D and E. E is consecutive to D. Okay? Which follows D? Angle E. Which follows E? Angle F. Which follows F? Angle C. Which follows C? Angle D. Okay? D, E, F, C. So the consecutive angles are supplementary. So we know what supplementary means. Taylor, what does that mean? Other things that we have to commit, right? If we want to pass the math test, you got to know. Y'all thought I was kidding when I said this, but I love it. To pass the class, you got to know what congruent means, and you got to know what supplementary means. Okay? And I'm not lying when I say that. So those are vocab words that you got to commit to memory. Congruent means identical. Supplementary means they have a sum of 180 degrees. That's the easiest way to say it. What does sum mean? To add together, and it equals 180, right? So angle B plus angle E equals 180. Angle E plus angle F equals 180. Angle F plus angle C equals 180. Well, that helps, right? Because I'm trying to find angle F. Okay? I'm trying to find angle F. So 42 plus angle F equals 180. That's all that they did right here. 42 plus angle F equals 180. That's how angle F ends up being 138 degrees. Okay? Consecutive angles are supplementary. All right. Let's see if we can do this one. This one's important as well. DG is 31. I'm trying to find D to F. Now, this was the question about diagonals. Do you know what a diagonal is? You ever played tic-tac-toe? Or Connect Four? You ever played Connect Four? Okay. Connect Four, you try and get 4 consecutive checkers, right? Okay. How can you get 4 consecutive? Up and down, vertical, horizontal, or what else? Diagonal. Diagonal, right? Vertical, horizontal, or diagonal, right? Okay. So in a parallelogram, the diagonals bisect each other. That means that DG is congruent to GF. That means that CG is congruent to GE. Okay? Since we know what congruent means, wait! So if DG is 31, what's GF, Taylor? Okay? So what would the whole distance from DF be? 62, right? Okay. Diagonals bisect each other. They cut. Remember, that means that they're cutting each other into 2 congruent segments. All right? When they intersect. Okay. This is what an example would look like. I'm not going to go through this. You want to know what you might see on the test. Okay? This might happen to you on a test. Right? There's a lot to it. JKLM is my parallelogram. What dot is missing? M. Guess what you have to do here? You got to find the coordinates of them, right? And you got to plot it and all that good stuff, correct? Okay. What type of tool do I have to find that particular point? Well, the first thing I can do is find the slope. Okay, I find the slope of the opposite side, which is LK, right? And LK would help, because remember, if the lines are parallel, they're going to have the same slope, right? Let's see what my slope was here. Rise, 1, 2, 3, 4, over run, 1, 2, 3, 4. Made that easy on you guys. I could go over here to point J. Guess what I'm going to do? Rise, 1, 2, 3, 4, over run, 1, 2, 3, 4. Hot dog, there's M. Okay? Right? That was pretty simple. Okay? I have to prove that it's a parallelogram, because not only are the opposite sides parallel, they're also congruent. They're also congruent, correct? So if I really wanted to, I could then use my slope formula to ensure that these two sides were congruent to each other. Really, I'd use the distance formula more than I would the slope. Okay? All right? I'm going to do something very odd. Let me continue on. I don't have too many more. Just a couple things that we need to enforce, okay? So here's what the halfway point means, right? You've got all of your properties. You've got the properties of parallelograms, okay? Let's review those real quickly. A four-sided polygon. This is my question. A four-sided polygon is called a what? A quadrilateral. A quadrilateral is a parallelogram if the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. Right? 5 properties. Okay? The rest of this lesson is kind of saying this. If I have these 5 properties, do I have a parallelogram? Right? So again, what we do in here all the time. We talk about the properties, right? We say we can use this property to prove it's a parallelogram. And then we say, if I have this property, is it a parallelogram? Right? We're jumping back and forth. Okay? All right. This is helpful, I think. I'm not going to write this down. To say, by definition, that a quadrilateral is a parallelogram, you've got to show the opposite sides are parallel. Okay? So, how do we show opposite sides are parallel? Use our slope formula. Rise over wood. So rise over run. Y2 minus Y1 over X2 minus X1. Okay? Change in Y over the change in X. Rise over run is easy to run. Come and get your right? So that if you want to like okay. All right. Yeah. So again, I'll just talk about this. You're going to be given the properties of the quadrilateral. You're going to have to tell if that quadrilateral is a parallelogram. To do this, use the definition of a parallelogram or the conditions below. We're going to run through some of these conditions. Okay? That's what we're going to be doing. Probably not too many. All right. Don't write these down. Just don't write them down. It's too confusing if you write them down. Okay, let's go over. If one pair of opposite sides of a quadrilateral are parallel and congruent, then we have a quadrilateral. I'm sorry, then we have a parallelogram. Think about what I just said. If one pair of the opposite sides are parallel and congruent, I've got a parallelogram. If both pairs of opposite sides are congruent, then I've got a parallelogram. So, one pair is parallel and congruent, I'm good. Or if both sides, both pairs of sides are congruent, I've got a parallelogram. If both pairs of opposite angles are congruent, I've got a parallelogram. So, what do we notice here? What's the pattern so far? One side can be parallel and congruent, and I'm good, correct? Both pairs of sides have to be congruent, or both pairs of angles have to be congruent. Okay? If an angle is supplementary to both of its consecutive angles, then I've got a parallelogram. Okay? So, angle X. Angle X plus angle B equals 180, and if angle X plus angle B equals 180, I've got a parallelogram. If diagonals of a quadrilateral bisect each other, then I've got a parallelogram. Right? So these things can be a little tricky when we talk about these conditions. Okay? I'll give you a really helpful picture there. You want to try to get parallel. Things like these. Okay? We're working towards that goal. Right? These are the types of problems you would verify, you would use. Okay? These are the types of problems that you would use to see whether or not you have a parallelogram. They give you, notice what happens here. They give you the variables to use. A is 3, B is 9. What are you going to do with 3? Plug it in for A. What are you going to do with 9? That should be very elementary right now. Okay? So 10 times 3 plus 4 has to equal 15 times 3 minus 11. Look what happens here. 10 times 3 plus 4 is 34. 15 times 3 minus 11 is 34. So how many sides right now are congruent? Yeah, those two sides. Remember the property. I've got to have 2 pairs of congruent sides. Okay? See that? That's why you can't just stop with one pair of congruent sides. Okay? Even though these sides might be congruent, you must prove that these are also congruent. And they are. Okay? Substitute B in, substitute 9 in for B. Right? You see that you can't just stop after one, though, right? Because that's the big teaching point. You've got to prove both pairs of sides are congruent. Yes, sir. Great question. If I had said substitute 8 in, okay, for B, and it's not congruent, it is a quadrilateral, but it's not a parallelogram. Okay? Or at least, since I don't have coordinate points, I don't know the slope, so I can't prove that the one congruent side is parallel to the other. So it's not, you can't conclude that it's a parallelogram. Okay? This is odd because we're doing like the proofs while we're doing the work, right? That makes sense to y'all? You're doing, instead of having to write out all the theorems and postulates, the proof's in the pudding, so to speak, okay? All right. What would happen here to show that this is a parallelogram? A has to be 2.4, B has to be 9. Okay? If I substitute 2.4 in for A, I get 7 times 2.4 and 2 times 2.4 plus 12. Okay. This means that PQ is congruent to RS, so that's good. Okay. And then I would substitute 9 in for B. 10 times 9 minus 16 plus 9 times 9 plus 25 equals 180. When I do all that, I get supplementary angles and I get parallel lines. Okay? Since I have parallel lines, by the way, how do I know that they're parallel? This would be, boy, if you got this right, you're ready for POC. Oh, this might be the most eye-opening thing you see. Imagine these were parallel lines, and this was a transversal. These two angles would be called same side interior angles. Okay? Right? Same side interior. Same side interior angles are what? Supplementary. Right? So remember the very first property we talked about? If one pair of sides is congruent and parallel, I've got a parallelogram, right? So I can prove that. Mr. King asked earlier, I don't know, I can't figure out the slope, right? But remember, now we can use these angles to prove if they're supplementary, then they're parallel. So that's kind of cool for geometry notation. Okay? All right. How would I prove that this is a parallelogram? I've got parallel lines here, parallel lines here. Okay? Notice alternate interior angles. Alternate interior angles are congruent. I've got parallel lines, correct? I have parallel lines in both of my both sides, then I've got a parallelogram. All right? Okay. I was going to run you through this, but I'm not because we're out of time and I need to get you to this classwork. Just so you know, in this one, number 1, I would have to plug in 4 for A, 5 for B, 2B equals B plus 5, 7A minus 6 equals 5A plus 2. Both of those statements have to be congruent. They have to be true to have a parallelogram. Down here, I have consecutive congruent angles. Is that what I want for parallelogram? No, I want consecutive supplementary angles. Okay? Right? I'm sure that you will have questions.